the topic reservoirs. In the previous classes, we have seen about the definition of a reservoir and the importance of rivers and types of reservoirs and how to select the reservoir and various terms related to the reservoirs we have seen. In the previous class, more particularly, we have concentrated on learning about the sedimentation or the silt deposition in the reservoir and how to estimate the life of the reservoir making use of this sediment analysis. Today's class, we concentrate on the separated topic like dams. So what are the dams and what are the various types of dams and how to select a particular type of a dam for a given condition and how to select a good site for a dam. These are the topics that we are going to take up today. By definition, a dam is an impervious barrier. So this is constructed across a river. So this barrier holds the water on the upstream side. It does not allow the water to flow to the downstream portion. This will be constructed across a river or maybe a stream, such that on the upstream side, a reservoir will be formed, and this reservoir stores the water. This stored water will facilitate the diversion of water from the river, or it may be used to retain the debris flowing in the river along with the flow of water. So the figures clearly depict a dam which is constructed across a river. Of course, this is the downstream portion of a dam. Similarly, in the second picture also, the downstream portion of the dam is shown. This picture provides you both the downstream and upstream aerial view. So dam is constructed and the top of the dam is used as a road connecting both the banks of the river. So you have on the upstream side the storage of water, on the downstream side the flow of water by opening one gate from the spillway or this is the flow of water taking place. Another pictures of the dam. So to give a complete idea about what a dam is, I try to provide several pictures here. You can see here the dam is slightly different. The reservoir is formed by constructing a dam, but the dam is not straight. This is appearing curved. So these types of dams are called arch dams. So this is the dam, the front view from the downstream side of a dam. So you have the left bank, you have the right bank. Connecting both the banks, a dam is constructed, and the top of the bank, at the top of these gates are provided. If you close these gates, the water will be stopped and stored on the upstream side, and if the gates are opened, the water flows to the downstream portion. Here is a small video. Just go through this. Yeah, this is a brief about the dams and the history of the dams in India. You must have seen that the history of the dams is more than 1,000 years in India. So we have several dams constructed in streams or various rivers. There are 36 cases where the dams were failed immediately after the construction. And it has been noticed that the failure for the dams is mainly because of the two reasons. One is that inappropriate design, maybe either overestimating or underestimating the floods, or the second case is that there is a structural failure for the dam. So both the cases will lead to the failure of the dams. There were certain deaths also as reported there. So dams may be classified on the basis of their function, purpose for which a dam is meant for, or maybe on the basis of hydraulic design based on the strength of the dam, what type of material is used for the construction of the dam, or depending on the structural design. Based on all these things, the dams will be classified. The selection of the type of a dam to be constructed at a particular site and the selection of site for a particular type of dam are based on several factors. There are two things. One is how to select a particular type of a dam for a given site. Second is how to select a suitable site for a particular type of dam. So these two, a wide study is to be done, is to be carried out to select a particular type of a dam at a given site or a particular site for a given type of dam. Various forces that are acting on a dam, in particular on a gravity dam, are to be considered in the designing of a dam. We see in detail about the classification of dams based on the function, the purpose, as you have seen the first case. The dams are classified like storage dam, diversion dam, detention dam, debris dam, or a coffer dam. Storage dam meant for storing the water. So this water will be impounded in the reservoir on the upstream side, and it will be supplied during the periods where there is no water or less water. The storage dam is meant to supply water for irrigation, maybe for domestic or industrial water supply, even for power generation. Usually the dam is meant to store water, required quantity of water for is sufficient for 1 year. So that is a storage dam. So water will be stored in a dam and released as and when it is required for various purposes. It is meant to store water which is required for 1 year. Is the storage dam. Why it is 1 year? Because immediately after that there will be recurrence. Once again monsoon season comes, water will be flowing into the reservoir. It can be stored there. Second category is the diversion dam. Particularly, this will help us in raising the water level in the river. When the water level rises in the river because of the construction of the dam, the water flows directly into the canal. This is called a diversion dam. Usually, the height of these diversion dams will be small, not very much height. Weir or a barrage comes to this category of a diversion dam. So when the diversion dam is constructed, normal period of flow, whatever water comes into the reservoir will be allowed to flow to the downstream portion. When the water level rises, the water enters into the canals and the water will be supplied. When more water is coming, that water is allowed to flow over the structure, reaches to the downstream portion. Thereby, the dam will safeguard the upstream portion without any problem of submergence. Third category is the detention dam. It detains the water during the flood period, allows this water to flow to the downstream portion under a very controlled condition. You can see here, the water gets stored here and it is moving. It is let off to the downstream portion in a very controlled conditions, so that downstream side there will not be much of impact or effect due to these high floods. Next category is the debris dam. So this dam is constructed to retain the debris, maybe sand, silt, or any driftwood flowing in the river can be stopped. So this is a debris dam. Coffer dam is another thing which you must already studied in your geotechnical engineering also. A temporary dam which is constructed to exclude the water from a specific area so that that area may be useful, may be used for constructing a dam, maybe to raise a pillar, to lay a foundation for a pier or abutment, etc. That is a coffer dam. Second category of the dams is based on the hydraulic design. The dams are classified like overflow dam, non-overflow dam, which allows water to flow over the top of the structure is called overflow dam. Example is a spillway. Non-overflow, it will not allow the water to flow over the top of it. It is a non-overflow. In this picture, you can see both the portions of a dam. The central portion is the overflow portion, and either side of this, you have a non-overflow portion, which does not allow the water to flow over it, whereas in an overflow portion allows the water to flow over. This is called the spillway. So a good dam design would be like consisting of non-overflow portion as well as the overflow portion. The third category is based on the strength. The dams are rigid and non-rigid dams. Rigid dam is which is made up of rigid material, which is not easily erodable, so permanent in nature. Non-rigid dam will be maybe earth or rock fill, maybe temporary in nature, non-rigid dams. Fourth category is based on the structural design. The dams are classified like gravity dam, arch dam, buttress dam, arched buttress dam, or earth dam. Gravity dam may be a concrete dam or a masonry dam. So it will resist all the forces which are coming onto the dam by the self-weight itself. Then it is called a gravity dam. Whenever a dam is constructed on the upstream side, there is water. So because of this water, there will be water pressure, hydrostatic water pressure will be there. Because the dam is constructed, there will be pressure which comes beneath the surface foundation. It is called uplift. So there will be several forces which may be acting onto the dam, and all these forces will be resisted by the self weight of the dam itself. Then it is called a gravity dam. On the other side, arch dam is a covered masonry or a concrete dam. So it could be a masonry or a concrete dam, but you can see here the shape of the dam, something like an arch, something like an arch. So this is a convex portion, upstream phase, and resist the forces exerted on it by this arch action. So in the arch dam, water pressure is resisted and transferred to the abutments by the arch action. So it could be a thrust or a bending moment. They may be of constant radius type. Sometimes the radius may be varying. It is called variable radius type, constant angle, or it can have a double curvature type, and arch gravity types are maybe there. So arch gravity dam resists the forces coming on it partly by gravity and partly by arch action. As you can see here in this figure, because you have an arch action here, the load that is to be resisted by this will be transferred by means of this to the abutments by means of this thrust and bending. As a result, the material used for constructing the dam will be less. So it becomes very economical. In other case, in the gravity dam, as we have seen, lot of material is to be used there, either masonry or concrete. The reason is the entire self weight of the dam should be able to resist all the forces coming onto the dam. Let it be a water pressure force, let it be earthquake force, let it be a wind force that is coming onto the dam, or uplift force, whatever pressure which weakens the dam is supposed to be resisted by the self weight itself. So because the self weight should be a resisting force, more and more self weight should be there to take care of more forces coming onto the dam. Such a problem is not there in the arch dam. You can see here, you have arch action. As a result, the material used for the arch dam will be very, very less. The moment less material is used for the arch dam, less cement, less concrete, naturally, it becomes more and more economical. But the problem, the issue related with the arch dam is that you should have very careful design. You should have very careful design. The design must be safe in terms of various types, whatever type that you take, maybe a constant radius or a variable radius, whatever type, that the constant angle, whatever type that you are taking, it should be designed more clearly. So a lot of skilled manpower is required to construct the dam also. Buttress dam on the other side consists of water retaining sloping membrane supported by a series of buttresses on the downstream side. So there will be a buttress, and this buttress will support the dam. So this is called the buttress dam. Some cases, upstream slab is replaced by multiple arches supported on the buttresses. So you have number of elements like arches, So that is the buttress dam. You can see in the figure, these are all the buttresses which are provided. All these buttresses support the dam. Then category is the Archdem. This is also called Embankment Dam. So this is belonging to the category of a non-rigid dam because you will be making use of the locally available earthen material to construct this dam. Since the earthen material is provided there to resist the various forces coming onto this, naturally it is not rigid in its type like a concrete dam or Archdem, which are very rigid, but the Archdem is non-rigid dam. Based on the method of construction, these earth dams are classified like rolled fill type, hydraulic fill type, semi-hydraulic fill type, and so on. The rolled fill earth dams may be once again homogeneous and zoned type or diaphragm type. We see once again clearly as we discuss about the earth dams in particular. Based on the material used for the construction, it is called concrete dam. It is classified like a concrete dam, earth dam, or a composite dam. So what is this composite dam? You may have part of it masonry or concrete and a part of it may be like earthen construction. So this will help to reduce the cost. Nagarjuna Sagar Dam belongs to the category of a composite dam. Then rockfill dam, big boulders will be used. So they will be placed and they will be completely roll filled. So it is a rockfill dam. Thereby an impervious layer will be formed. Steel dam. So material used is steel, lesser height, suitable for smaller works. Other category is the timber dams, purely temporary purpose. Timber planks will be inserted one by one, which are kept in the grooves and supported. There could be sufficient quantity of water leakage also. Because they are temporary, it doesn't matter. So the front view of a dam is shown here. So you can see here another type of arch dam provided with no gates. Since there is no gate, up to spillway crest level, the water will be stored and the remaining water flows to the downstream portion. Now we see about the advantages and the disadvantages of various types of dams. How to select a particular type of dam. We need to understand which dam is advantageous and what category it is advantageous, etc. Merits and demerits of various types of dams. Gravity dam. So this will resist the overturning moment of water pressure by the self weight itself. I told you a lot of weight will be there for a gravity dam to resist all the forces which are coming. So this is the non-overflow portion of a gravity dam and overflow portion of a gravity dam. What are the various forces which are coming? So this is the self weight of the dam. On the upstream side, reservoir is formed because there is a water in stored condition. Water pressure will be there. Downstream side, there will be tailwater. So the force which is causing the tailwater pressure in the opposite direction. Uplift pressure will be there because the dam is placed on a foundation. There will be uplift pressure. So all these forces like water pressure or uplift pressure will try to turn the dam, overturn the dam. So weight of the dam should be such that it should be able to resist all these forces coming onto the dam. So you can see here a typical cross section of a gravity dam is shown. This is called the upstream phase of the dam. Sometimes this upstream phase will be purely vertical. Sometimes at the heel portion, slope also will be provided. We'll come back once again why this slope is provided. The slope is provided to make the dam more stable at the moment. Please try to learn to that extent. To provide more stability to the dam, the upstream slope will be provided. Else, it will be fully vertical. And downstream phase will be a sloping phase like this. And this is all the reservoir. So top of the surface known as the headrace. So upstream phase forming a reservoir. because there is a reservoir on the upstream side, water pressure will be there on the dam. Top water, the top surface of the dam is called crest, and you have tailwater. Up to this tailwater level will be there. So this is the tailwater. This is the headrace level. The advantages of the gravity dam, they are very strong, they are very stable, and because you are using a masonry or concrete, overflow portion also can be constructed in the middle of the dam itself wherever required at a suitable location. Another advantage with the gravity dam is they can be constructed to any height. As high as 800 meters we have the dams. To any height, the dams can be constructed, provided you have suitable foundation available for it. Maintenance cost of this gravity dams also is very less. The dam do not fail suddenly, so sufficient warning will be given. You can take up the repair works and extend the life of the dam also. The sluices will be provided in the body of the dam itself, so that certain portion of the silt can be scoured through these sluices. They are cheaper and they will be useful for the long time. The disadvantages for the gravity dam is they have to be constructed on a good foundation. So sound rock foundation is required. A huge weight you are trying to place. If the foundation is not good, there may be differential settlements at the foundation. If there are differential settlements, failure of the dam takes place. Second disadvantage is you are constructing with a very costly material like concrete or masonry. So the cost is very high. Initial cost is high. Skilled labor are required for constructing the dam. You are making use of concrete or masonry. Skilled labor are required. And another disadvantage is they don't allow the subsequent raise of the height of the dam. If the dam height is 100 meters, design, you have to construct only up to 100 meters. You can't later raise. The problem is because you are using concrete, there may be a good joint that comes up from 100 meters to maybe another 10 meters. When you want to go for subsequent raise, it becomes a problem. The joint may not be good, failure may take place. Second is the Archdem. As we already indicated, in the case of Archdem, there will be currents. Because the arch action is provided, the load will be transmitted and it will be shared by the thrust and bending moment. Size of the Archdem or volume of material required for the Archdem will be less as compared to a gravity dam. Usually, length to height of the Archdem will be less than 5. The advantage of the Archdem is rock foundation need not be as strong as in the case of a gravity dam. And the section of the dam is much less compared to the gravity dam. Problem of uplift pressure also will be very, very minor. The strength of material used in the construction of arch dam is more fully developed than in the gravity dams. So it is so easy to construct an arch dam compared to that of a gravity dam in terms of using huge material. The disadvantage is skilled labor anyway are required for this. The process of construction is slow and abutments should be very, very strong, which are provided at the end, which are to take care of the arch action. So the arch dam section, on the top view, it may appear like this. This is the arch action. So this is the arch dam, a small video.
Archdem is curved in plan with its convex face holding the water. This structure is less massive when compared to the gravity dam. The force exerted by the stored water on the upstream side will be transferred to the abutments by the arch action. This dam is suitable for narrow valleys, but the major requirement is sound abutments. In this case, uplift on the base of the dam has no problem because only abutments are going to bear the maximum force. An arch dam will be economical only if the length of the dam is less than its height. Therefore, this is preferable for very great heights. According to the method of construction, arch dams are classified into constant radius arch dam, constant angle arch dam, and variable radius and variable angle arch dam. Arch dams.
Okay, so you must have seen now very clearly in this video how an arch dam would be, types of the arch dam, advantages of the arch dam compared to that of a gravity dam we have seen. One very specific point which is very interesting in the case of arch dam is because arch action is provided there, the material used would be very less. Other thing is that if this arch dam is provided in between two big hills or hillocks, then height of the dam could be more and the water can be retained on the upstream side with this arch action. Okay, so the third category, buttress dam, and this buttress dam consists of number of buttresses or piers. They are dividing the entire space into number of spans. So you'll have number of arch actions, number of arch dams connected together is the buttress dam. Per unit length of the dam, buttress dams require less concrete, 30 to 40% than that of a solid dam. So the cost is less quantity of material is used, and problem of temperature control in concrete is minimum, less uplift pressure, less maintenance, and excavation costs also will be less in the case of buttress dams. Powerhouse switchheads can be provided in between the buttresses, so the spacing of buttresses can be varied to utilize the zones of good foundation, and they require relatively weaker foundation compared to that of gravity dam. Stress distribution is more uniform, and head dissipation is better, and construction also will be very speedy, and access is possible to the backside of the buttress. The disadvantage is richer mix of concrete is required. You cannot go with a simple M15, M20, M25. More complicated formwork, skilled labor are required. They are susceptible to damage or destruction by sabotage of or military action more easily than in the case of a massive dam. They are very sensitive to the moderate deterioration of concrete. Much care is required during the construction. Very slow pace of construction, and reinforcement is used. Small size aggregate is required. Bigger aggregate cannot be used because there should not be any void spaces in forming the concrete. More joints will be there. We need to take greater attention, and they do not permit easy means of providing the openings for the sluices and penstocks. Overflow arrangements require a complicated layout. Number of water sieves to be provided and maintained is more. So this is the arch action. Steel dams, as we have been indicating, only steel, stainless steel or steel is used. So they are cheaper compared to the rigid dams. But only thing is, while preparing the steel dam, life is very short because the water will be directly in contact with this steel. There is a problem of rusting. So constant maintenance is required. And they have to be properly anchored at the foundation. Otherwise, that portion will be washed. Timber dam, the cost is so low, but the height cannot be more. Maximum 10 meters height may be useful. Very temporary in nature, the timber dam. Maintenance is so high because timber is used coming directly in contact with water, so life is very short. Huge seepage loss will be there through these timber joints. Earth dam is good one way. The advantage with the earth dam is that highly economical because you are using locally available gravel, soil, etc. The disadvantage is that the height cannot be much. I mean, as in the case of a concrete dam, as we have seen, 800 meters also will be the height, but here up to 40-45 meters maximum can be constructed. Only 40-45 meters will be constructed. Second disadvantage with the earth dam is they are not very rigid in nature. If there is any big flood, flash flood, suddenly which is coming without any warning, so there is a problem that the dam may be washed off or breaches may be taking place. Maintenance also is very high in the case of these earth dams. And spillway must be necessarily provided, but unfortunately this cannot be directly provided in the main dam portion. So you need to have separate concrete spillway at a very good suitable location. And the last one is the rockfill dams. They are good, but they are very cheap also compared to the other concrete or masonry, gravity or arch dams. And they cannot be constructed to a very higher heights, but they are also temporary in nature. Composite dam is combination of the dam, like earth dam plus masonry dam, earth dam plus concrete dam is a composite dam. So these are all various types of the dams, the merits and demerits of different types of